Installing fiber optic cable in Class Roman 2 Division 1 locations requires careful attention to detail to ensure safety and prevent potential hazards. These locations are defined as areas where combustible dust is present in sufficient quantities to produce explosive or ignitable mixtures. The National Electrical Code, or NEC, provides guidelines for electrical installations in these hazardous environments. Firstly, use cables with a suitable flame rating. This is crucial to prevent the spread of fire in case of an ignition event. Look for cables that are specifically listed and labeled for use in Class Roman 2 Division 1 locations. These cables are designed to resist flame propagation and minimize the risk of fire spreading along the cable pathway. The flame rating will be indicated on the cable jacket, often with markings such as CL2 or CL3, but always confirm that the specific cable is approved for Class Roman 2 Division 1 environments according to the NEC. Secondly, secure cables to prevent damage. Proper support and securement are essential to protect the fiber optic cables from physical stress and potential damage. Use appropriate cable ties, straps, or clamps that are designed for the specific cable type and size. Ensure that the supports are installed at intervals that comply with the NEC and cable manufacturer's recommendations. Avoid over-tightening the cable ties or straps, as this can crush the cable and damage the optical fibers inside. Thirdly, avoid placing cables in areas where they may be exposed to physical damage. Route the fiber optic cables in a way that minimizes the risk of impact, abrasion, or other forms of physical damage. Consider using conduit or cable trays to provide additional protection in areas where the cables may be vulnerable. Keep the cables away from sharp edges, moving equipment, or areas where they could be accidentally stepped on or run over. Fourthly, protect cables from moisture and chemicals. Fiber optic cables can be susceptible to damage from moisture and certain chemicals. Protect the cables from exposure to these elements by using appropriate sealing methods and enclosures. If the cables are installed in a damp or wet location, use waterproof connectors and sealing glands to prevent moisture from entering the cable. Consider using a chemical-resistant cable jacket if the cables may be exposed to corrosive chemicals. Ensure that the enclosures and fittings used to protect the cables are also rated for the specific environmental conditions. Additional considerations should be taken into account during installation, including grounding and bonding. While fiber optic cables themselves do not conduct electricity, any metallic components, such as cable shields or connectors, must be properly grounded and bonded to prevent the buildup of static electricity and to provide a path for fault currents in case of an electrical fault. Follow the NEC guidelines for grounding and bonding in Class Roman 2 Division 1 locations. Furthermore, proper training and certification are essential for personnel installing fiber optic cables in Class Roman 2 Division 1 locations. Installers should be familiar with the NEC requirements, safety procedures, and best practices for working in hazardous environments. They should also be trained on the proper techniques for handling and terminating fiber optic cables. Regular inspections and maintenance are crucial to ensure the continued integrity of the fiber optic cable installation. Inspect the cables and connections periodically for any signs of damage, wear, or corrosion. Replace any damaged or deteriorated components promptly. Keep the area around the cables clean and free of dust and debris. By following these guidelines, you can ensure the safe and reliable installation of fiber optic cables in Class Roman 2 Division 1 locations. Remember to always consult the NEC and other applicable codes and standards for specific requirements in your area. Class Roman 2 Division 1 locations necessitate the use of suitable flame-rated cables to mitigate fire hazards. These cables are engineered to resist flame propagation, thereby minimizing the spread of fire in the event of an ignition. It is imperative to select cables that are specifically listed and labeled for use in Class Roman 2 Division 1 environments, ensuring compliance with safety standards and regulations. Securement of fiber optic cables is paramount to prevent damage and maintain the integrity of the installation. Cables must be adequately supported and secured using appropriate cable ties, straps, or clamps designed for this specific cable type and size. The support should be installed at intervals that adhere to both the NEC guidelines and the cable manufacturer's recommendations. Care should be taken to avoid over-tightening the cable ties or straps, as this can lead to crushing of the cable and damage to the optical fibers within. Avoiding areas prone to physical damage is crucial for protecting fiber optic cables and ensuring their longevity. Cables should be routed in a manner that minimizes the risk of impact, abrasion, or other forms of physical damage. The use of conduit or cable trays can provide additional protection in areas where cables are particularly vulnerable. It is essential to keep cables away from sharp edges, moving equipment, and areas where they could be accidentally stepped on or run over, reducing the likelihood of damage and potential hazards. Protection from moisture and chemicals is vital to maintain the performance and reliability of fiber optic cables. Fiber optic cables are susceptible to damage from moisture and certain chemicals, necessitating the implementation of protective measures. This includes the use of waterproof connectors and sealing glands in damp or wet locations to prevent moisture ingress into the cable. If cables are likely to be exposed to corrosive chemicals, the use of a chemical-resistant cable jacket is recommended. Enclosures and fittings used to protect the cables should also be rated for the specific environmental conditions to ensure comprehensive protection. Grounding and bonding are critical considerations during fiber optic cable installation in Class Roman II Division I locations. While fiber optic cables themselves do not conduct electricity, any metallic components, such as cable shields or connectors, must be properly grounded and bonded. This grounding and bonding serves to prevent the build-up of static electricity and provide a path for fault currents in the event of an electrical fault. Adherence to the NEC guidelines for grounding and bonding in Class Roman II Division I locations is essential for safety and compliance. Proper training and certification are indispensable for personnel involved in the installation of fiber optic cables in Class Roman II Division I locations. Installers should possess a thorough understanding of the NEC requirements, safety procedures, and best practices for working in hazardous environments. They should also be proficient in the techniques for handling and terminating fiber optic cables to ensure proper installation and functionality. Regular inspections and maintenance are necessary to ensure the continued integrity of the fiber optic cable installation. Periodic inspections of the cables and connections should be conducted to identify any signs of damage, wear, or corrosion. Any damaged or deteriorated component should be replaced promptly to prevent further issues. Maintaining a clean environment around the cables free of dust and debris is also important for optimal performance and longevity. In summary, the installation of fiber optic cables in Class Roman II Division I locations demands meticulous attention to detail and adherence to safety guidelines. By using suitable flame-rated cables, securing cables to prevent damage, avoiding areas prone to physical damage, protecting cables from moisture and chemicals, ensuring proper grounding and bonding, providing adequate training and certification for installers, and conducting regular inspections and maintenance, the safety and reliability of the installation can be ensured. Always consult the NEC and other applicable codes and standards for specific requirements in your area to guarantee compliance and safety. The selection of appropriate fiber optic cables for Class Roman II Division I locations is contingent upon their ability to meet specific flame resistance criteria. These cables must be designed and tested to prevent the propagation of flames, thereby mitigating the risk of fire in the event of an ignition. Flame-rated cables are typically constructed with materials that exhibit low smoke and flame characteristics, minimizing the potential for hazardous conditions in the surrounding environment. It is essential to verify that the selected cables are certified and listed for use in Class Roman II Division I locations by a recognized testing laboratory, ensuring compliance with industry standards and regulations. Proper securement of fiber optic cables is crucial to prevent damage and ensure the long-term reliability of the installation. Cables should be securely fastened to support structures using appropriate cable ties, clamps, or straps that are specifically designed for fiber optic cables. The spacing between support points should comply with the manufacturer's recommendations and relevant industry standards to prevent excessive sagging or strain on the cables. It is important to avoid over-tightening the fastening devices, as this can cause damage to the cable jacket and underlying optical fibers, potentially compromising the performance of the system. Physical protection of fiber optic cables is essential to safeguard them from potential damage caused by impact, abrasion, or other mechanical stresses. Cables should be routed in a manner that minimizes exposure to potential hazards such as sharp edges, moving equipment, or areas where they could be accidentally stepped on or run over. In areas where the risk of physical damage is high, cables should be enclosed in conduit, cable trays, or other protective structures to provide an additional layer of protection. The selection of appropriate protective measures should be based on a thorough assessment of the environmental conditions and potential hazards present in the installation location. Protection against moisture and chemical exposure is critical to maintaining the integrity of fiber optic cables in harsh environments. Moisture can penetrate the cable jacket and cause corrosion of the optical fibers, leading to signal degradation and eventual failure. Similarly, exposure to certain chemicals can degrade the cable jacket and other components, compromising the cable's structural integrity. To prevent moisture and chemical ingress, cables should be installed with appropriate sealing methods and enclosures. Waterproof connectors, sealing glands, and chemical-resistant cable jackets can be used to protect the cables from these environmental hazards. Regular inspection should be conducted to identify any signs of moisture or chemical damage, and appropriate corrective action should be taken promptly. Grounding and bonding of metallic components associated with fiber optic cable installations are essential for ensuring electrical safety. While fiber optic cables themselves are non-conductive, any metallic components, such as cable shields, connectors, or enclosures, must be properly grounded and bonded to prevent the buildup of static electricity and provide a path for fault currents in the event of an electrical fault. Grounding and bonding should be performed in accordance with the NEC and other applicable electrical codes. The grounding and bonding system should be designed to minimize the risk of electrical shock and prevent damage to equipment and personnel. Training and certification of personnel involved in the installation of fiber optic cables are crucial for ensuring that the work is performed safely and effectively. Installers should be trained in the proper handling, termination, and testing of fiber optic cables. They should also be familiar with the relevant industry standards and regulations, including the NEC requirements for installations in hazardous locations. Certification programs offered by recognized industry organizations can provide installers with the knowledge and skills necessary to perform their work to the highest standards. Regular inspections and maintenance are essential for maintaining the long-term reliability of fiber optic cable installations. Inspections should be conducted periodically to identify any signs of damage, wear, or corrosion. Maintenance activities such as cleaning connectors, re-terminating damaged cables, and replacing worn components should be performed as needed to ensure that the system continues to operate at peak performance. A well-documented maintenance program can help to identify and address potential problems before they lead to costly downtime or system failures. In addition to the aforementioned considerations, it is important to adhere to the manufacturer's recommendations for the installation and handling of fiber optic cables. The manufacturer's specifications provide valuable information regarding cable bending radius, pulling tension, and other critical parameters that must be followed to prevent damage to the cables. Failure to adhere to the manufacturer's recommendations can void the warranty and compromise the performance of the system. The design of a fiber optic cable installation in a Class Roman II Division 1 location should take into account the specific environmental conditions and potential hazards present at the site. Factors such as temperature, humidity, dust levels, and chemical exposure should be considered when selecting the appropriate cable type, connectors, and enclosures. A thorough risk assessment should be conducted to identify potential hazards and develop appropriate mitigation strategies. The installation should be designed to minimize the risk of damage to the cables and ensure the safety of personnel. The use of appropriate labeling and signage is essential for identifying fiber optic cables and components in a Class Roman II Division 1 location. Cables should be clearly labeled with their function, destination, and any other relevant information. Signage should be posted to warn personnel of potential hazards and provide instructions for safe operation and maintenance. Proper labeling and signage can help to prevent accidental damage to the cables and ensure that personnel are aware of the potential risks. Documentation of the fiber optic cable installation is essential for future maintenance and troubleshooting. A complete set of documentation should include drawings, specifications, test results, and maintenance records. The documentation should be stored in a safe and accessible location and updated whenever changes are made to the installation. Proper documentation can help to expedite troubleshooting and ensure that maintenance activities are performed correctly. Compliance with all applicable codes, standards, and regulations is essential for ensuring the safety and reliability of a fiber optic cable installation in a Class Roman II Division 1 location. The NEC provides detailed requirements for electrical installations in hazardous locations. Other relevant standards and regulations may also apply, depending on the specific application and location. It is important to consult with qualified professionals to ensure that the installation complies with all applicable requirements. The selection of appropriate fiber optic connectors is crucial for maintaining signal integrity and ensuring reliable performance in a Class Roman II Division 1 location. Connectors should be selected based on the cable type, application, and environmental conditions. Waterproof connectors should be used in damp or wet locations to prevent moisture ingress. Chemical-resistant connectors should be used in areas where the cables may be exposed to corrosive chemicals. The connectors should be properly installed and terminated to ensure a secure and reliable connection. The use of appropriate tools and equipment is essential for the proper installation and termination of fiber optic cables. Specialized tools are required for cutting, stripping, and polishing the cables. Fusion splicers are used to join two fibers together with a low-loss connection. Optical time domain reflectometers, or OTRs, are used to test the integrity of the cables and identify any faults or defects. It is important to use high-quality tools and equipment to ensure that the installation is performed correctly and that the cables are not damaged. The testing of fiber optic cables is an essential step in the installation process. Testing should be performed after the cables have been installed and terminated to verify that they are functioning correctly. An OTR can be used to measure the cable length, attenuation, and reflectance. A light source and power meter can be used to measure the optical power at the end of the cable. The test results should be compared to the manufacturer's specifications to ensure that the cables meet the required performance criteria. The implementation of a quality control program is essential for ensuring that fiber optic cable installations are performed to the highest standards. The program should include procedures for inspecting materials, monitoring workmanship, and testing finished installations. Regular audits should be conducted to identify any deficiencies and implement corrective actions. A well-designed quality control program can help to prevent errors, reduce rework, and ensure that the installation is reliable and meets the customer's expectations. Furthermore, emergency shutdown procedures must be in place. Class Roman II Division 1 locations involve the risk of fire and explosion. It is paramount to implement emergency shutdown procedures that isolate power from electrical equipment, including fiber optic systems, in case of such an event. These procedures should be clearly documented, regularly practiced, and readily accessible to all personnel. In conclusion, fiber optic cable installation in Class Roman II Division 1 areas involves many important things. It is crucial to select flame retardant cable and to protect them from hazards.